Okay, this is number 5 in section 2.1. And so we have the same directions because I did number 3. So we have our second order homogeneous linear equation here, and we're given two linearly independent solutions, right? So they're already given. So these are your two linearly independent solutions. And then, of course, we're given our initial conditions. So we want to find the particular solution, but we can find the general solution first, since we know the general solution is in the form of C1y1 plus C2y2, right, according to this problem. So we're given our y1 and y2. They're right here, right, in order again. In honor of Valentine's Day, I'm going to use pink and purple. So we have C1y. Well, C1 we're going to determine in a bit, and y1 is e to the x, right? I mean, it's the same guy. And plus C2 and y2 is e to the 2x. Okay, so there is my general solution. So general solution. So now we're ready to find our particular solution. We just have to find C1 and C2, right? That's our next step. So find C1 and C2. So this was step 1, and this is going to be step 2. Okay, so let's our imposition of initial conditions. So imposition of initial conditions. And so we have a second order differential equation, and so we're going to find our first derivative. And so we have y prime of x. Well, here's our, right, this is our y of x, right? And, right, it's a function of x, e to the x and 2 to the x. So we have the derivative is c1 e to the x plus 2c2 e to the 2x. Okay, so now we can impose, okay, so we have y of 0 is 1. Okay, y of 0. Okay, that's y of 0, so I'm definitely using this one because there's no derivative. So y of 0 is, let's see, and actually, well, I mean, the same guy, but I'm really looking at that one. So we have c1 e to the 0 plus c2 e to the, well, 0, or 2 times 0. That's going to be equal to 1, right? I'm using this initial condition. And what is that going to imply? Well, that's going to imply, well, this is just a big 1, right? C1 times 1 is C1 plus, again, that's a big 1. E to the 0 is 1. C2 equals 1. Okay, so I'm going to go ahead and box this. And notice we did not generate our C1 automatically, but we will find it. And our C prime, or y1 of x, or y1 of 0, because we're imposing our initial conditions. Okay, so I'm going to use this guy now and insert our 0 for x. So again, c1 e to the 0 plus 2 c2 e to the 0. And y prime of 0 is 0. So that's going to be equal to 0. And again, these are big 1s. So we get c1 plus 2c2 equals 0. Okay, so here are two equations in two variables. So this is a system, right, of linear equations. So we can put those together. So we have c1 plus c2 equals 1, c1 plus 2c2 equals 0. And, I mean, from algebra, we can solve this using substitution, elimination, matrices. It doesn't matter. It's only a two equation and two variable system, so it's pretty easy to solve. So I'm going to use, I don't know, I'm going to solve this system by substitution. Again, if you want to use elimination, that's fine. I'm going to solve for, I guess, the first equation. So I'm just going to solve for C2. So I know C2 is 1 minus C1. And that's C2. So I'm just going to insert it, right? Substitute back. So I get C1 plus 2, and then C2 is this guy. Right, so now I have an equation in C1, and I can just distribute. And let's see, I'm left with negative C1, that's a plus, plus 2 equals 0. And then, of course, if I subtract 2, right, and then, well, I'll just leave that here. And then, of course, divide by 1. So C1 is equal to 2. And I can definitely find C2 because I can just insert it back. And I get C2 is equal to 1 minus 2, which is negative 1. Okay, so that's my C2. So I'm ready to write my YP, Y particular, and just going back to my original, where was my original? Okay, so it's right here. Right, way up here. Okay, so I have y equals, let me erase that. Okay, y equals C1 y1 plus C2, well, I know my e, okay, this is really e to the x, e to the 2x. Okay, just so I don't have to keep scrolling. Okay, so y particular, so yp of x is equal to C1, well, C1 is 2, e to the x plus C2, which in this case is negative 1, so we can even just write negative. Well, you can write negative 1, but it's just really negative e to the 2x. So that is my particular solution, right? So impose your initial conditions to the general equation, or to the general solution to obtain your particular solution. So that's pretty much it, and let's see, in honor of Valentine's Day, or Valentine's Day weekend. Yay!